So the next topic is determining sample size. So we're going to look at two different cases like we have done previously. So we look at the case where we are talking about population mean mu, and then the second case would be when we talk about population proportion pi. So they both follow the same kind of sequence logic. So sampling error, or in other words the margin of error, is what it is related to. So if you take a confidence interval, so it is you take the sample mean and then we subtract from that margin of error, add margin of error, and we get the confidence interval. So how big is that margin of error, or what determines the size of the margin of error? Okay, there are two things that are involved in computing margin of error. So the z value and then the standard error value. Okay, the sigma, whether it is known or unknown, if it is known, it is a fixed number. If it is unknown, it comes from the sample, and again, it is a number that you cannot control. The only two numbers that you can control are z and n. How do you control z? Well, if you want 90% confidence interval, then you get 1z. But if you want 95% confidence interval, you get a slightly larger z. And if you want 99% confidence interval, then z gets even larger. So the confidence level you want determines the value of z, and thus determines the size of the margin of error. If you want more confidence, then the margin of error will become bigger and bigger, because you want to allow for the sampling error to have that additional confidence. So by increasing the confidence level, you increase the margin of error. So if you want to decrease the margin of error, one could say, well, why not we decrease the level of confidence we want? But that defeats the purpose, because you want to have a high level of confidence in your confidence interval. So you do want 95 or 99% confidence level. So you don't want to change the confidence level. So what other thing you can do? Well, what other variable affects the size of the margin of error? Well, n does. If you have larger sample, then this standard error value goes down. As n increases, the standard error goes down. So when the standard error goes down, this product value of this product will go down. So as sample size increases, the margin of error will go down, and the size of the confidence interval will become tighter, and therefore it will become more meaningful and useful. So increasing the sample size decreases the margin of error. Decreasing the sample size will increase the margin of error, in other words, the width of the confidence interval. So if you don't want to give up on your confidence level, you still want to keep 95% or 98% or 99% confidence level, but at the same time you want to decrease the margin of error and make the confidence interval narrow, then the only alternative you have is to have a larger sample. So increase the sample size. So how big a sample size do we need? So that starts from how big a margin of error at a given confidence level you can tolerate. Okay. So once you have the E settled, so you want a given E and given confidence level, E and Z are fixed, then you take the margin of error, which the margin of error is this. Now you switch terms and you get n equal to that. So this is the formula we'll use. Z comes from the confidence level, 98%, 95%, whatever that you desire. And again, margin of error E is something that you set, and you want to be able to estimate the population mean mu within that particular margin of error. Then you plug it in and you get the estimate for sample size. So let's look at an example. Now let's look at an example. Example 8.38. Okay, survey is planned to determine the mean annual family medical expenses of employees of a large company. So the management of the company wishes to be 95% confidence. We want to have 95% confidence level, and we want the sample mean to be within plus or minus $50 of the population mean, or we want to limit your margin of error to just 50. And we have a previous study, and that indicated that the standard deviation is approximately 400. So if you don't know the value of sigma, what you need to do is to take a pilot sample, compute the standard deviation of the pilot sample, and use that in place of sigma. So we have 400 as our estimate for sigma. So we want confidence level is 95%. Okay. And we have sigma of 400. Okay. And the margin of error is $50. You want to be within $50. So alpha is 1 minus confidence level. So z is, we'll simply use the norm.s.inv function. So that will be 1 minus alpha over 2 the cumulative probability. So n is then, so we apply that formula for n, which is the z square that value times sigma square that value divided by margin of error and square that value, and you get your estimated sample. Now you want to round it up. You round the sample size, always round it up. So you can use the round up function of that, comma 0 for you want to round it to 0 decimal places. So that's our sample size. Now B, if management wants to be correct within plus or minus $25, that is if the margin of error is 25, so you can now, keeping the confidence level at 95, you want the margin of error to be smaller, then you should now be prepared to take even a larger sample. So margin of error is 25, then z squared times sigma squared divided by e squared. So that means we copy the rounding formula here and you get 984. So you need to be able to take 984 observations in the sample, then you will achieve the margin of error that you desired at the confidence level you desire.